Okay, I think it's recording now. And I know that some people have said that it wasn't, my voice wasn't being heard on some of the videos. So if this little this light on my thing ever turns red, let me know, because I think it's the headset. Okay. If not, I'll keep playing around with it until I get it to work. Sometimes it's working and sometimes it's not. But here we have an isosceles triangle, and it is very important that we do an isosceles triangle here. Okay, I'm trying to get this to show up, and it's not even, is it writing? We're not even writing. Is it writing over there? Oh, look at that. Isn't that fun? Okay. Let's try something else. All right, let's see if it works now. Okay, we are going to bisect angle B. You should have found something specific about these two constructions. Did you notice anything? If you were precise and exact, something special should have happened. Anybody find it? They're the exact same line. So I'm going to say that one more time because it's going to be on your quiz. It's the exact same line. Okay? When you have an angle bisector and a perpendicular bisector to its opposite side, and an isosceles triangle, they're the same. So if we're simply going to just bisect the angle, let's start with that. And it's not going to let me do that for some reason. I have no idea why. It's going to want me to do it from all the way back here. So if I want to bisect this angle, remember what you do. You're going to make an arc across, and then you're going to move it here. You're going to make an arc in the middle of the angle. You're going to move it to the other side and make another arc. And then what do I do at this point? Just connect them. I'm going to connect them all the way down because I've also found the midpoint of AC. Because this point here happens to also be, it's not writing on my smartboard for some reason. It's also going to be this point here is also going to be the midpoint. Okay? So that only happens in what kind of triangles? Isosceles triangles. So that's pretty important. Okay? It's pretty important to recognize that it is an isosceles triangle there. Now, I didn't actually do the construction of the midpoint of AC, but I could have. Remember, midpoint is found by which of the four constructions that we know? Shh, come on, folks. Midpoint is found by which of the four constructions that we know? Perpendicular bisector, okay? So you sometimes might need to actually do that construction fully. The people were asking me about where to put the construction notes. They go in the foundations unit. So those 4 pages that you were asked to print, if you would please put those in the foundation section of your binder. And then the worksheet, the 1-7, goes with coordinate geometry, and that should be our second unit. Okay? What I'm going to do here is I'm going to talk a little bit about our coordinate geometry unit as a whole, and then I'm going to be specific about the homework. I graded number 10 for homework, and there were lots of issues with number 10. Very few people got them right. Those questions 10, 11, and 12. So what we need to do is make sure that we understand that question because it will be on your quiz next class. Thank you, sweetie. So what I'm handing you right now is what we like to call one of your summative assessments for MYP geometry. Now that's really big words to simply mean it's a project, okay, that we're going to work on throughout this unit. Now, most of you that if you're in MYP geometry means you're taking MYP other classes as well. And to be in MYP at the end of your second year of MYP, you're going to get what's called an MYP certificate, which hopefully leads you into taking IB courses. Now, to complete your certificate, you have to take MYP courses, graded on what we call MYP rubrics. you have to do so many hours of community service, and you have to do a project, an MYP project, we call it. Now, this is the first of at least 4 different MYP assessments you will do in this class. And what I like to do is we're going to be giving them to you at the beginning of the unit, so you kind of know what to expect as we go along. And you will be able to, every day we'll do something new, and you'll be able to do another part of this assessment. And the next day you'll do something different, and you can do more of this assessment. So by the end of the unit, you should be able to have it fully complete. Does that make sense? Okay. Now, the very first part, I want you to go ahead and take a minute and read right underneath where it says lost at sea. And don't read the table part, but just that little paragraph there. So when you read that first paragraph, you're kind of being told what your job is. In a way, you can kind of think about yourself as like a cartographer. We have a map. And if you actually flip to the very last page, I actually give you a map, okay, that has some things on it. We have some radar stations. You have some places out in the Pacific Ocean that we're going to be looking at, okay? So you have your map to go by. Notice you have the point 0, 0, which means you have the origin already located on your map, and you're going to be doing some things based on those Cartesian coordinates, or those planes, or those points there. So basically what we're trying to do, and this is near Thailand, in case we talk about the Thai, the Royal Thai Coast Guard, and they're trying to find a lost ship. And so your job is going to be to help them to find this ship. Now, the very first page talks about the rubric that's going to be used. When you're talking about an MYP assignment in this particular class, all MYP math classes are graded on one of 4 criterion. And this particular one is graded on criterion A, which stands for knowledge and understanding. Basically, do you know the math or do you not? Okay? And there are 3 other criterion. Right now, I can't remember what they stand for, but something is like, one of them is called communication, where you have to be able to communicate effectively in the written word, and yes, that means in mathematics as well. You have to, I think it's reasoning is one of them. So we'll come by, once we get to the other criterion, I'll explain what they all are. Throughout the year, you'll be assessed twice on each of the 4, so a total of 8 times we'll be using these MYP grading rubrics, okay? But today we're going to be talking about knowledge and understanding. Notice knowledge and understanding has a score from 0 to 8. Do you see that? Okay? And so I'm telling you in advance what you have to do correctly to get all the way to the best score possible. Now, you will get an MYP grade, which gets recorded and in the grade book and goes to Mr. Hunniford, who is in charge of all the MYP assessments. And you will also get a regular grade, like a percentage grade in the grade book for geometry. Okay? A 7 and an 8 together, either one, correlates to an A. A 5 or a 6 would be a B. So if you want to write that right next to it, you can. Okay, a 7 and an 8 would be an A. A 5 and a 6 would be a B. A 3 and a 4, a C. A 1, a 2, a D. And a 0, if you didn't turn it in, is obviously a 0, an F. Okay? Now, every MYP assessment, in order to get the full level 8, you will have to complete what we call an unfamiliar question. So let's go ahead and just start there. Can everyone flip all the way to question 8 for me first? I'm sorry, question 9. It's question 9, the very last question. So read that question, and there's probably something in there that you have no idea how to do. Is there a word in there that you aren't sure how to calculate? Bearing? Bearing is something I won't teach you, because if I do, then it wouldn't be considered a level 8 MYP assessment. Does that make sense? You have to do the research on your own. You have to go outside of your comfort zone to be able to understand what bearing is. After you turn it in, of course, I will go over it. Now, can you get an A with still not getting that question right? Yes, right? You still can. So it's okay. You just have to get everything else correct. But to get that full level of understanding, way past, above and beyond, we like to say, you need to be able to go and research what a bearing is. It's not difficult. It's not something you can't do. It's just an unfamiliar question. Yes?
So what if we get a couple of questions wrong?
So, well, you're still not going to get the full A. Because if you look, what it says here, in order to get the A, if you go back to the front page, you have to get everything up to that point correct. Do you see that? It says you have correctly answered question 9 and most of the preceding questions 6, 7, and 8. Most meaning if you make one little calculation error, I can probably give it to you. Okay? But that's really, it depends. If you make several calculation errors, probably not. Okay? So I'm going to keep this with you. You're going to keep this with you and bring it with you to class. We're going to be working on it throughout the year, throughout the unit. If you go ahead and look at question 1, you can flip the page and look at question 1. You should be able to answer question 1 now. Okay? It just says look at the map and write the coordinates of the places. You can do that, right? It's just writing coordinates down. That is something you should be able to do ahead of time. You know how to do that, right? So that's something you can do. When we get to level 2, we haven't gone through the equation yet. Okay? We're going to do the midpoint. You should be able to answer question 3. It says find the coordinates of the midpoint. You should be able to do that one. There's some words in here like gradient. That's the international word for slope. So I put slope in parentheses there to kind of let you know what that is. We're going to talk about slope on Wednesday after the quiz, and we'll continue on. You are going to be dealing with fractions. Okay, please leave them in fractional form. No decimals here. Okay? All right, go ahead and keep this with you. Okay? There is something that when you turn this in, which will be on the day of the test, okay, you're going to turn this in the day of the test on coordinate geometry, which will be next week. You're going to turn it in along with what we call an honor pledge. And I don't know if your other teachers and other of your MYP classes have talked to you about it yet, but you will do an honor pledge, and I will print them off for you, and you will sign them and staple it to this. Honor pledge simply means the following, okay? And this is important not only for this assignment, but really for homework assignments or anything like that. We take the honor pledge very seriously here at Stonewall, okay? I have had many students not get their certificate and not get their IB diploma. Colleges have been notified because they violated the honor code. And what does that mean exactly? That means that this work is going to be your own. You didn't copy it from somebody else. You didn't work together. I hate that word. I will tell you when it's okay to work together. This assignment, it is absolutely 100% not okay to work together. Okay? Not okay. But there are lots of times where I want you to work together, just not on this. Does that make sense? Okay, so you will basically say I didn't work with anybody else. Now, are you allowed to go on the internet to answer question 9? Yes, because you can do your research, right? So that part is okay. Can you go and research where all the answers are to this assignment? No. Do we understand the difference? Okay? So yes, you can research what a bearing is and how to find it with a protractor. Okay, that's you doing research to try to answer the question. But finding an actual answer key and copying it, not okay. Are we good? All right. Go ahead and put that away for me then, because we're done with that. And I want to talk about midpoint homework. So if you would please go ahead and look at your 1-7. I believe it was 1 through 14 that you had to do. I graded number 10. The answer to number 10 was 12, negative 28. And I think only a handful of us got that. So I definitely want to go over that question. Unfortunately, I don't have the answer key because when I made this, well, maybe I do. Let me see if I can find one real quick. It's possible. Not probable. Here are the answers to your homework. They're in red there. I can't make it any bigger. I'm sorry. But I graded number 10. So go ahead and look at your answers, and then let's decide, besides number 10, another one that we need to go over. You're having a quiz next class on midpoint, on constructions, and then on distance, what we do today. So what other questions besides number 10 did you want to go over? 10 is difficult because 10, they gave you the midpoint. And I think that when you guys were doing your homework, you just went ahead and said, I'll just find the midpoint of, the 2 points that are given to me. You really need to read the question. Questions 10, 11, and 12, you're not asked to find the midpoint. You're given it. You're asked to find the other endpoint. Okay? So I can think it's a handful of people that got it right, but most of us didn't. So you weren't really following the directions. So let's start with 10, and if you have any other questions, we can look at that as well, okay? All right. So question 10. You are given, I'm going to borrow somebody's real quick if you don't mind. All right. So question 10, you're given the midpoint of RS. Is 6, negative 10. And we are given S to be 0, 8. We need to find R. Okay? So remember the formula for midpoint is this. X equals, the x of the midpoint is equal to the x coordinate of the midpoint is the sum of the two endpoint values divided by 2. So we have to pay attention to what numbers go where. Okay, so Taylor, tell me what number goes on the left-hand side of my equal sign. What is the x-coordinate of the midpoint? 6. So you should have a 6 on the left-hand side. Okay? How about x1 or x2? What is the x-coordinate of one of the endpoints, Alex? 0. Good. I don't know the other one, so I'm going to leave it as an x because that's the unknown value. And now I'm going to go ahead and solve it for x. Stephanie, do you remember what we did last class and how we solved this for x? Very good. To get rid of my fraction, I'm going to multiply both sides by 2. Perfect. And that gives me 12 is equal to 0 plus x. X is just 12. Good. So that's where the 12 came from as the x-coordinate of the other endpoint. Okay? Now I have to do the same thing, but now for y. So I'm going to go ahead and pause the recording, and I want you, those of you who didn't get it right the first time, go ahead and find the y-coordinate of our other endpoint here. We should have gotten the y-coordinate as well. We know that the formula is simply this. Since this is our midpoint, 10 goes there, or negative 10, my apologies. We know that 8 is the other y-coordinate. We multiply both sides by 2, and then we subtract our 8, and that's where the negative 28 came from. Okay? Now, if you remember, there is a way to verify it using a graph. What's going to be the problem with trying to use a graph in this case? The numbers are huge. So you would have to have a really big coordinate plane. It wouldn't even fit on the one that I have on the wall. Okay? So when the numbers are small, I agree. A graph is a pretty quick, easy way to double check. Go from one endpoint to the midpoint, and then do the same thing again. But the algebra should be okay if we're going to be in MYP. Okay? All right. Let's go ahead now. I'm going to pass the tape around. If you have a tape at your desk, 6 pieces of tape, just kind of put them off to the side. Go ahead and get out that cardstock piece of paper for coordinate geometry. I believe it was a blue piece of paper. And if you would, go ahead and tape down with the line side on the back. Tape down all 6 of our cards, okay? And then I'll pause the recording for just a second. Tape. While we're waiting for tape, if you're not already waiting for tape, we're going to do 3. We're going to do the 3 on the left-hand side first, and then we'll leave the 3 on the right-hand side for after the quiz. The first one we already know. So if you don't have them taped yet, you can just fill out the cards. Okay? So on the non-line side, I want you to write midpoint. So the first card is going to be midpoint. Okay? We could technically make this a construction, couldn't we? Because we know how to find the midpoint of a segment with a compass, simply the perpendicular bisector. But since we're talking about coordinate geometry specifically, we'll leave the constructions for our foundations unit. Okay? So on the back of this, I just simply want you to write the formula. Okay? You can draw a picture of what a midpoint is if you want. On the front, I don't care. Okay? So you can just say it's halfway between. That's fine if you want to draw that in the front. What do these little tick marks mean again? They're congruent. Okay? So you can say simply that AM, the measure of AM equals the measure of MB. This is all in the front. And AM is congruent to MB. Okay? So all in the front. That's what midpoint is on the front of the note card. On the back of the note card, we'll write the formula. Okay? That's just what it is. That is an example of a midpoint. So on the back, I want you to write the formula for the midpoint. And we know what that is right now. The sum of the two endpoints. Okay? And we can write it this way. It's going to equal the x-coordinate of the midpoint, the y-coordinate of the midpoint. Because sometimes we know the midpoint, like in question number 10, right? We know what the midpoint is. Has everyone gotten tape? Your table? Dina, would you hand that to the table behind you if you finish? Thank you. Everybody else has tape? Okay, so midpoint. We know what a midpoint is. We've been working with it now for a couple days. On the second card, we're going to do the Pythagorean theorem, because I'm going to show you today how the Pythagorean theorem is related to the distance formula. And you guys already know what the Pythagorean theorem is, because you did it back in middle school. So on card 2, you're going to do the Pythagorean theorem. Okay? So card 2 is the Pythagorean theorem. What kind of a triangle is used with Pythagorean theorem? Nope. Could be isosceles, but it has to be a right triangle. If I'm trying to find the distance between 2 points, I want to find the distance, the length, from this point to this point. And I put them on a coordinate plane. I can make a right triangle and use the Pythagorean theorem. I'm trying to find this length. You can simply drop down a vertical and drop a horizontal and find A and B and make a right triangle. That goes on the front. Okay? Do we remember what goes on the back? What is the Pythagorean theorem? Something squared plus something squared. A squared plus B squared equals C squared. Good. So if we're trying to find the length of the hypotenuse, A squared plus B squared is equal to C squared. You're trying to find this guy. Okay? Remember this? So we're going to do one like that. You can use the Pythagorean theorem to find the length of some segments. It's possible. Now, without a calculator, you might have to leave your answer with the radical, because I don't expect you to know exactly what the square root of 12 is. Okay, but you could approximate it. So Pythagorean theorem is one of two ways to find length, to find distance. And then the last one is going to be something called the distance formula, which I also believe you did in middle school, or in algebra. You tell me which one you did it in. Have you done it before? You know what I'm even talking about. Maybe if I write the formula down, you'd know. If I write the formula, maybe it'll look better. The distance formula. This would be card 3. I believe you've done it before, but I could be wrong. If you are literally just trying to find the length between 2 points, we're going to use x1, y1, x2, y2. Simply have 2 points. That goes on the front. You're finding the distance between 2 points on a coordinate plane. I want to find the length of that segment. So see if this looks familiar to you. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. I think it was algebra that you did it. Algebra 1? Maybe pre-algebra, I'm not sure. But that's the formula. And yes, I expect you to know the formula. So we'll need to practice. When do I subtract? When do I add? Okay? So that's going to be important. Notice you subtract the x's, you subtract the y's. When do I add the x's and add the y's? Midpoint. So midpoint I'm adding, distance I'm subtracting them. Then I'm squaring, adding the squares and square root. Whew. I don't know about you, but Pythagorean theorem seems a lot easier to me. Pythagorean theorem is easier to me than this. A squared plus b squared equals c squared. Can I show you something, though? Don't write this down. But let's just investigate something for a second. Don't write this down. Just kind of watch. Do you agree that this is true? If this is the distance formula, can't I just square both sides and get this? Isn't the undoing of the square a square root? Okay, so can I go from the red to the blue? Are we okay with that? I just squared both sides and I got rid of the square root, that's all. Well, notice what happens. I'm trying to find this. I'm trying to find the distance. And if you look back up here, isn't this the d? Distance between them? Notice something. The distance between these x values is simply just a, isn't it? If I did a squared plus b squared equals c squared. So if I subtract the x's and square them, I get this. If I subtract the y's, I get this. So a squared plus b squared plus c squared is really just this. This is a squared, this is b squared, and this is c squared. The Pythagorean theorem is just the distance formula. It's just more numbers to worry about. Okay, it's not hard. They're the same thing. Okay, I'm supposed to show that to you. So, do we have our 3 note cards? That's the important part right now. Got the 3 note cards? Okay. So you can put that right back into your binder. Okay, we'll add the other 3 note cards. You can go ahead and have them taped. That's fine. We'll add those later. We're going to use those for equations of lines and slope. Okay? But go ahead and take your notes out for today. I want you to label them distance with today's date. So go ahead and get a blank piece of paper. If you want to do it on graph paper, I would suggest that. So if you have graph paper, taking notes on your graph paper today might be easier, okay, because we're going to be drawing some coordinate planes. So I would suggest graph paper. To review, the hypotenuse is the longest side. It's the side that's always across from the right angle. And we know that the other two sides are called legs. Okay? So C is always the longest side. It's the length we're trying to find. We're trying to find the distance between these 2 points. Okay? So let's try a problem with the Pythagorean theorem, and let's see what happens. So I have on your graph, I want you to create a coordinate plane like I have here. If you need a straight edge, feel free to borrow a straight edge, that's fine. But we're going to graph the points 4, -1, and -3, 5. So I want you to graph those two, and then we're going to use the actual Pythagorean theorem to find the distance between them, or the length between the 2 points. Okay? Okay. We have the point 4, -1 is going to be in quadrant 4. And then we have -3, 5 is going to be in quadrant 2. I did ask that we just connect them because I do want us to actually find the length of that particular segment. So let's see if I can get it to look exact. There we go. And if I want to use the Pythagorean theorem to do this, I need to create a right triangle. And I see that some of us are already doing that, and that's fantastic. So if you would, go ahead and create the right triangle where this would be the hypotenuse. And there really are 2 ways to do it. Most of us look like they're going to draw it this way, which is totally okay. But could I, if I wanted to be different, could I have drawn it this way? Right? Either way is okay with me. Did anybody draw it that way? I'm the only oddball? All right, figures. I'll draw it your way. Fine. All right, right triangle. We're trying to find this distance, right? So we know that c squared is equal to. Whenever I'm trying to find the length of an exactly vertical line or an exactly horizontal line, I can just count it. Isn't that nice? So when it's exactly horizontal or vertical, you can just simply count. So if I'm going to call this A and this B, and honestly, it doesn't really matter, okay, which one is A and which one is B. We have 1, 2, 3, 4, 5, 6. So this length here is going to be a length of 6. And when we go across the bottom, we're going to count again. We have 7. Double check me. I think that's right. Is that what you guys got? So let's plug those numbers in. 6 squared plus 7 squared. And it's a matter of just solving it now. These are things I would expect you to be able to do without a calculator. I do expect that you can square 6 and square 7 and add them together. So let's do that. So 6 squared is what? Okay. 36, and then 7 squared is? All right, I was scared there for a minute. If I add them together, 85. And then what do I need to do to solve for C? Square root both sides. We're talking about a distance, so I don't have to worry about plus or minus. Could you approximate what that is? Estimate to the best of your ability? It's about what? What's the closest perfect square that's closest to 85? Well, 81, right? So that would be 9. Square root of 81. So would you agree it's about 9.1 maybe? We're approximating it. It is okay to leave it as a square root of 85. Okay, I will accept both. But how quick was that, right? So easy. A lot of teachers don't teach Pythagorean theorem. I think it's so much easier than the distance formula. And I don't think I will, I'm trying to think on the quiz, I don't think I say using the distance formula. There are times where it's better to use one than the other, but honestly, this is my go-to. Okay, I think it's just quicker. Let's try the same problem using the distance formula. Okay, so in your notes, I know you have them in your note card, but I do want you to write the distance formula down if you don't already have it in your notes. So you should have it in two places. One place on the note card, and then one place in your notes. Yes, ma'am. I counted. I went 1. I just counted down. If it's vertical, you can just count. If it's slanted like that, you can't, which is why I created a right triangle. So because I can count the left side and I can count the bottom. Okay, good question. Go ahead and put that Pythagorean distance formula into your notes, and let's use the same points and do it the other way, because there's two ways to find length. One way is to create the right triangle and find it, and then the other way would be the distance formula. Okay? Just worry about the formula. You don't have to write all this, what it stands for, and blah, 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 blah. Just the formula is all you need. Just this guy. Okay? So let's try the same problem. Same 2 points. Okay? So we want to graph those again. I guess you already have the graph, don't you? So we don't need to graph it again. But we should use the formula and it should come out the exact same, shouldn't it? We should get the square root of 85. So let's double check it. Let's plug in what we know. My question is, which one is 0.1 and which one is 0.2? How do I know? Is the first one given to us always 0.1? Does it matter? Doesn't matter as long as you're consistent. If you're going to call this 0.1, then it needs to be 0.1 all the time. I mean, I don't care what point you call it. So at the beginning, I kind of like to write the little letters above it, just so I know. I know where they go in the formula. Okay? The first coordinates are x1, y1. The second one will pretend to be x2, y2. We're not going to pretend. We're going to really do it. Okay? So let's take those numbers now and plug them in. We're going to have to be extremely careful of the negatives. When you subtract a negative, it becomes a positive. When you square a negative, it becomes a positive. So we're going to have to be real careful. We can plug them in. x2 is -3. x1 is 4. y2 is 5. y1 is -1. Please also, something that's just the math teacher in me, please extend your square root all the way to the end, because it's all underneath that square root, okay? It's just, I'm particular. So being careful with our negatives. What do we do next? Knowing what I know about the order of operations, what do I do next? Start the inside of what? The parentheses? Perfect. Good job, my mom. So -3 minus 4 is what? -7. Squared plus. And then I do the other set of parentheses, and I get 5 minus a -1. +6. Good, because when you subtract a negative, it becomes positive. Those numbers look familiar to you, don't they? Because if you did the Pythagorean theorem and we counted, we got 7 on one side and 6 on the other. So, and when you square a negative, what happens? Becomes a positive. So these numbers should be the same, and they are here. So we have the square root of 49 plus 36, which is the square root of 85. So we got the exact same answer. Exactly. But this one dealt a little bit more with negatives and being real careful about squaring them and paying attention to your signs. Okay? So we have about 15 minutes left. I'm going to give you some problems to work on specific to distance. But I want to make sure that we're aware about, for our quiz next class, I will answer all your questions on homework first. So if you have questions on distance, definitely ask them. You'll take your quiz, and it covers 3 things. There's going to be 3 parts to it. Your quiz is going to cover the basic constructions. And they will be similar to what you had to do today. Construct the angle bisector of an angle in a shape. Okay? Things like that. Basic constructions. It will cover midpoint. And within midpoint, I'm going to write parentheses other endpoint. Do you know what I mean when I say that? It's like that question numbers 10 through 11. I'm sorry, 10 through 10, 11, 12. 10 through 12 on your homework. It covers both. Can you find the midpoint? Or if I'm given the midpoint, can I find the other endpoint? And then distance, both Pythagorean theorem and the formula. Okay, so you're going to practice the ladder here for a little bit before you leave, and then you will study for your quiz. Okay, kiss me up. When? Next class, Wednesday.